Welcome to Project Geospatial. This is the Geospatial Frontier Virtual Technology Fair, hosted by Project Geospatial, but in partnership with the American Geographical Society. And joining us with this session as a special highlight on Spire is Keith Johnson. And Keith, let's start by telling us a little bit about yourself and talking about an overview of the company.
Absolutely. Thank you, Adam. Really appreciate being here, especially with the conditions that we're dealing with and trying to work virtually. Very exciting. But my background is 40 years of government sales. And for the last 20 plus, it has been setting up government's business for startups. And so, believe it or not, this is my sixth startup. And very excited to be at Spire. It's a great time. It's kind of like being in the wild, wild frontier. There's lots of really exciting projects and missions to solve and issues to deal with. So got a great team, and we're really excited about being part of your show.
Excellent. So just to have a little brief one-on-one discussion with you real quick about the company, what kinds of satellites do you build? Can we get into that a little bit before we dive into more of the details and what the company is all about?
Sure. So we build 3U satellites, and we have 3 payloads in each satellite, and then we collect the data and bring it down through our ground stations, and we sell that data as a subscription. What we're hoping is that as the markets mature and the technology matures, that the adoption of data from space becomes part of a regular business practice for solving mission-critical applications or different types of environmental issues.
Excellent. Now, what kind of data are we talking about here?
So we have AIS ship tracking data, which is used extremely widely for maritime domain awareness, both in the commercial aspects, hedge funds, shipping companies, and then as well as in the military space, where you're looking at policing the oceans or rescue missions, things like that are really important today.
So that has a pretty diverse set of business verticals that can go down, right? So can you give us an idea of what kind of current customers that you have across the board?
Absolutely. So in the commercial space, we have, like I said, shipping companies, major shipping companies, as well as manufacturing companies that are delivering goods via the oceans and want to know where ships are at all times. It used to be that when a ship left Singapore, we didn't know for 6,000 miles later that it was in New York. Now we want to know exactly where it is so it can have a direct impact on things like the stock market, supply chains, and things like that. And in the government, as I said, we've got plenty of use cases around maritime domain awareness.
Excellent. Are there any issues with ITAR and export control with that?
No. So, as you'll hear, we manufacture them in Glasgow, and we then are flying in Leo. And so we have all the right FCC licenses and regulatory issues. When it comes to ITAR, sometimes when we're building some of our satellites for our space as a service, we need to do some of the assembly in the United States, and it can't be done in Glasgow. But for the most part, we're a global company providing data globally.
Well, I want to keep this conversation dynamic here in terms of what Spire provides to the community. Do you want to show any kind of demo first, or do you want to go into some more of the questions and talk about, for example, one of the questions I have is what frequency range does Spire work with? You mentioned aircraft and AIS, but what does that mean across the spectrum of what you can collect? Or is that more appropriate for showcasing what you can do?
Well, I would answer it this way. We build our own software-defined radio, and we can listen from point 1 to 13 gigahertz. So when you look at the different spectrums that we're licensed to, whether it's VHF or UHF, each of those have a specific frequency. We're not just vacuuming up a large swath of signals. We are tuning to a very specific signal. I like to equate it to when I used to listen to the baseball games when I was a kid on AM. I'd have to turn it to exact frequency to hear the game, and then as soon as I got back into bed to listen to the game, the signal would be lost. I'd have to get back up and turn it again and keep adjusting it. We're collecting a very specific signal. We're bringing it down. We're processing it, and we're doing lots of artificial intelligence and machine learning against that signal so that we can then deliver a product that is usable and consumable by our customers.
Excellent. And that goes into, I don't want to get into Q&A too early, but I think because of what you just said, this crosses over into a question we just received from the audience in terms of what's the maximum coverage of a footprint in terms of what you can collect. And I do want to remind the audience that, it's a good question. It's valid in terms of what area can the satellite collect as it's passing over in an orbit. But also remember that this is also a UR signals collection platform, not imagery focused. As most of the companies that we've covered in the Geospatial Frontier Conference have been imagery focused, aside from a few companies. But I think this is a very relevant question to understand your capabilities as well.
Absolutely, and that's a really distinguishing point. We're not taking any pictures. We're listening. And so when we're listening, we have what you would equate to in the imagery space, a field of view. We're listening to signals. We have 88 satellites in orbit today, so we have them constantly going around and collecting RF signals, whether it's AIS, ADS-B, or weather, and then we're downloading those to our ground stations and then processing that to an end product. So we're not just snapping, pictures at a particular time. We're listening at all times.
How do you make sure that data is secure coming down?
So from collection to user, it's AES 256 today. We will implement tighter security issues as we go forward in building out the federal business. But at this time, that's been good enough to satisfy our customers.
Now, I want to bring up that when I was at the GeoIn Symposium last year and had a chance to speak with Spire, you all offer many more services other than just collection of signals. For example, you have orbital service offerings as well. Can you go into that a little bit more?
Yeah, sure. So we like I said, we have 3 payloads in our spacecrafts of the 88 satellites. They are a standard data collection product that we sell as a subscription. That's the AIS, the ADS-B for plane tracking, and radio occultation for weather. What we do as a fourth component of the business is do what we call orbital services or space as a service. And so Spire can put a satellite in orbit in less than 12 months with a payload that you choose in a relatively inexpensive way. We have currently a systems integrator who has purchased 3 satellites to be in orbit this year. We have a Five Eyes that purchased 1 satellite to test. So these are all proof of concepts to put a collection device up of data that they require, and then if it can be processed and determined that it helps the mission, they will want to build out their own constellation over time. So these are very exciting opportunities, and we've had these conversations with many, many different organizations, whether it's the Army, the Air Force, about building out constellations to support missions. We're not trying to replace geostationary exquisite capabilities. We're trying to take that percentage of RF collection or some type of signal collection that could aid and help in our countries meeting their missions.
Well, that certainly broadens your offerings quite a bit to allow your customers to build new constellations focused on their mission sets. That's much more diverse than just collecting signals. That's for sure. So with that said, I want to talk about a little bit about what percentage of your business is commercial and government.
So that's a good question. I would tell you the federal business has had explosive growth. We started it in 2017 with one individual, myself, and we're now up to 15 in less than 2.5 years. And that is based on revenue attainment, not on the fact that I might be a nice guy or not be a nice guy. And so we're doing some really unique things, and we have a tremendous pipeline. Commercially, we have a very robust business practice where they're looking at AIS as a repeatable sales process with a sales engine that's generating revenue on a very predictable basis. The same with the ADSB engine, and the same with the weather. What we're doing a little different in Federal is that we're combining all our data sets to provide our customers a visualization of something that's really critical. For example, we had to take our shipping data and marry that with our weather data so that organizations could do course corrections on ships based on weather. This was just a proof of concept, but it was hugely successful. And you're actually going to see that demonstration from Janie as we get through our conversation today.
Excellent. And before we get to that, just one or two last minute questions for our conversation is I want to, because Spire is a very unique constellation focusing on RF signal collection through various different frequencies. I want to. What has been the challenges that Spire has overcome since you started the business?
That's a great question, and they've been certainly many. Starting with one of the most complex but easily able to handle is just data rights in general. For example, everybody's used to data and they think data is free. But we have a venture-backed company that has spent hundreds of millions of dollars to build this constellation. And so we have to narrow the data rights usage. We can't allow it to be sold once and then say all the Navy gets to use it. That would put us out of business. And so going through that maturation process and having them understand that, it's kind of like buying a software product. You can't share with all your friends. You have data rights. So we constantly have to work through that process and help organizations understand that for the data and the value, we can come up with a reasonable price. Another kind of obstacle has been, there's been a lot of naysayers about the CubeSat transition from the geostationary or MEO. They're not so sure they want us to be successful. So we've had a lot of push in both government and systems integrators trying to make them understand that there is a space for the CubeSat business and that it can really help lower costs and get more capabilities in space. And that's something that's taken some time. And it's it's never supposed to be easy when you're doing a startup or making a transition and you have that chasm in the middle of your way. So we're working through some of these things. But luckily, everybody seems to understand and is willing to give us a shot and let us see if we can convince them that it makes a huge difference in what they're trying to accomplish.
Now, as early as a couple of days ago, the NOAA released a new statement regarding relaxing a lot of the imagery restrictions for the community as a whole. Do you have similar policy constraints for what you are doing and things that you're trying to overcome on that level?
I think the one area that I would share is that, we're collecting 10,000 radio occultations a day. That is a amount of radio occultations that is significant, scientifically significant to improve weather forecasting and predicting. But part of the problem is you have to take that data and you must assimilate it first and then come out with your process. And so we're ahead of the game when it comes to collecting the data. Nobody thought it could be done this soon, this early, and this amount. And so we know that if people could ingest our radio occultation, it would have an immediate direct impact on their capabilities. Example is that during this COVID crisis, the planes being grounded to some degree, they have had significant loss in AMDAR, TAMDAR data. Using radio occultation to supplant that would really be beneficial, especially coming up to the hurricane season and trying to make sure that the forecasts are accurate enough. I mean, we just saw that cyclone in Bangladesh that took out a lot of people. That was terrible. We need to have better forecasting and predicting so that we can save lives and infrastructure. And radio occultation is the answer, and it's not from Spire's perspective. It's from the scientist community. They have done the evaluation for years and know that it makes a difference. And so what we need to do is that adoption. We need budget process to help get the money there to consume the data, and we're excited about the opportunity in front of us.
And just to clarify what you just said, and you've hinted at this a couple of times during the conversation in terms of what kinds of signals and the use cases involved. Just the fact that the Spire satellites can monitor weather as well, and that's I want to say that out loud. You're capable of doing that.
So what we're doing is we're measuring certain criteria, and that then allows us, when we process it, to do things like soil moisture, sea ice, temperature, precipitation. Those are the variables that we're collecting from radio occultation. And that data then can be ingested in anybody's global model. So we've had UK Met and ECMWF. They're all evaluating and using our data. We've had NOAA do data pilots 1 and 2 and evaluate it. We had the Air Force do a data pilot. All of those reports are going to come out positive that it makes a direct impact in their ability to forecast and predict weather.
So I have a ton of questions coming in. I want to let the audience know that we're going to get to a Q&A session after the demo. Is there anything else we want to touch on before we do that? And then we can come back to some of these as it relates.
Are you referring to me?
Yes, Keith.
No, I'm good. That's good. You threw me for a curve. I thought I was going to present a script, but this was just as well. And I think we've covered all the points in the script. So this has been excellent. So I think to set up the demo, what has happened here is that when I first got here, we had data, but it's kind of like, how do you show the data to show that it's valuable in a mission critical application? So without any visualization tools, it was kind of like talking about it esoterically. So we initially started out with MapLarge to build this solution, and it really is very powerful, and it's a great selling solution. So their people are out selling their product, but they're using our data to help, and we're out selling their product with their data. We also did the same thing with Esri, so ArcGIS. So we have a agreement with them, and so you're going to see both products. We also have another one with BAE. We're not going to show that one today, but you're going to see Esri and MapLarge, and Janie's going to walk you through tracking ships and planes and weather on top of it, and I think it's really, really powerful. And the last thing I would close with, as we continue to build out our satellites and sensors and collect more data, we have this flywheel approach that all data supports the other data, so we can put these on visualization tools. So, for example, if somebody said, I want to start tracking sat phones, if somebody wanted to pay to put a sensor in space or a constellation, that would just be another data point on this type of map or visualization tool. So I'll throw it to Janie when you guys are ready.
Yep, so this is Janie Rechko. I'm the product marketing manager for the Spire Federal team. Great. So as Keith was mentioning, this is our Spire Fusion tool, which we created with our partner MapLarge. And within this tool, we have both our AIS data, so ship tracking data, and some of our weather variables. So we'll take a look at both. So if I go up here on some of these filters, I can turn on latest observation. And now you can see we're looking at all the ships that we're tracking in real time around the globe. So that's about 211,000 vessels that we're tracking. So I'll zoom in on this kind of a specific area, just so we can get a little bit more nuance. So just looking in at kind of the South China Sea area. So you can see obviously a lot of vessels that we're tracking in this area. And each of these little triangles is a different vessel. So as you see, as I roll over each one, we can get a little bit more information, more details on each. And I'm going to quickly color these by just by ship type, so you can sort of see the nuance there. So you see up here, we have a different color for different ship types. So a lot of cargo ships around this area, but fishing vessels and pleasure crafts as well. And so again, if we roll over and then if we click on a vessel, we'll get additional information on the vessel, the MMSI, the ship type, as we mentioned, and kind of information on its position. And then you can also see here visually, we have the history of its track, so where it kind of came from. That's this purple track here. And the other thing we can do with this tool is look at predicted position. So if we flip on predicted position, we're looking at all the same ships, but now this is the predicted position in 15-minute increments, up to 8 hours will show. So we can look at, some of the ships that I clicked on previously, and you can see it'll show the historical track, and then we'll have kind of the predicted track is that white piece there that you can see. We have some information about that. So we have all that vessel data. So I'm going to flip back just to latest observation. So then the other thing that we have is some of the environmental layers that you'll see here. So I think one that is pretty interesting we can turn on is wind speed. So that might take a second to load up, but once it does, you'll see that we actually show both the speed of the wind, and that's with that color scale in the corner, but then also the directions. You can see that we have this visualization of where the wind is actually moving. And part of the reason we were asked to make this tool was for this purpose of looking at different weather elements and how that might impact likely shipping routes, and how we might see ships kind of change course, change direction to avoid certain types of inclement weather. So that was sort of the purpose of the tool here. So we have wind speed, and as you can see, there's humidity and temperature, so different layers that we can turn on and have that different color scale in the corner. And so the other thing we can do is looking at some of the advanced filters. As I showed you, we can color by different filters. So we can do by speed as opposed to ship type. And so again, that will show you how kind of fast each of these ships are moving. So a variety of things that we've added in here that we can play with. And then I think the last piece I wanted to show you here is how easy it is also to download the data. So if we flip to advanced filters, we can actually create a geofilter and draw kind of a bounding box in a certain region. So say we want all of the ship data in this region. So you'll see it will focus just on those ships. And then we can view export ship data, and we can include the history, and we can include prediction. And if we click view report, and it might take a second to load, but it then downloads this data in kind of an easy sort of Excel format that you can look at. And you'll see here, it shows you kind of how we collected the data and flag name and heading and all this different information, the classification of the ship, and the history and the prediction data. So that's our tool with MapLarge. And now I'm going to move into our Spire operations dashboard, which if some of you are Esri users, you might be familiar with this kind of visualization. So again, another kind of global visualization. I've zoomed in here on the Gulf of Mexico just to give you an idea of what it looks like. But in this tool, we have our ship data and our aircraft data. I think we have to zoom in a little bit more to look at aircraft, but I can do that in a minute. So we have ship data, aircraft data, weather as well, which I'll show, and then some other kind of interesting data points to help put some of the data into context. So we have ports and airports, and then you'll see protractions here as well, since we had some oil and gas customers that were interested in us overlaying that information on the map. So again, we have ships here kind of colored by types. We have cargo ships, other types of vessels, service vessels, I think fishing vessels, tankers. So again, just an easy way to kind of look and classify the different types of ships. And when we click, we get additional details about this ship. And the other thing you'll see here is the source. So we have, for our AIS data, we have data coming in from our satellites, but we also combine that with terrestrial data, as well as our dynamic AIS, which is something we added this year that gives us kind of an additional amount of MMSIs, specifically in high traffic zones. So you'll see a lot of the ships in this area are coming in from dynamic, which is essentially ship to ship AIS messages that we then that then get sent over satellite internet and go directly into our API. So basically, they kind of avoid the issue of collision that happens often in high traffic zones in terms of AIS messages. So essentially, we've added a lot of information to our data set through that. And so then the last piece I wanted to show is, so we have the vessels here in the view. And then we had certain maritime customers who were interested in seeing, weather reports, but for their vessels in that area. So if we flip to weather forecast, we can sort of see the different weather forecasts related to the actual ship activity and the ships in that zone. And so you see we'll have wave height and sea temperature in addition to other kinds of like weather variables. And this forecast is actually for the ships kind of in that view that you're looking at. So fairly specific and useful for some of our maritime customers who wanted to get an idea of, what wave heights and sea temperatures looked like kind of in their area. And so those are our tools that we use to visualize our data. Thanks.
Okay, let's switch back to Keith and we'll go into Q&A. We do have a lot of questions coming in. Stand by here. All right, Keith. Thank you, Janie, for that demonstration. So let's see here. I want to start with, actually, there's a couple questions coming in about the demo itself. Is that okay, Keith? First one here, I'm going to go backwards here from what we got in. Is it possible to see the raw signal ellipses in the tools that you demoed or get those through an API?
Okay, so the question was, how do we deliver and what can you look at our data? We have, on most of our data, we have 3 different ways to deliver the data. We have raw data, we have message data, and we have API data. And so depending upon the requirements and the visualization tool or the analytics tool, we can deliver it in different types of formats. We have JSON files, we have GRIB files. So we're a data company. If we can't figure out how to get the data to you, then we probably shouldn't be in the data company.
Excellent. So in that you touched on both the questions there between APIs and signal ellipses. I think there's a huge community out there that likes to analyze the raw data themselves and figure out what other use cases they can develop. So once again, appreciate the answer. Another question that we had come in is, you actually answered this one as well. What export options that your tool can bring out? And you mentioned GeoJSON and several other formats. Is there anything else that you want to touch on that one?
Yeah, so the one thing that I mentioned earlier on is that this is like the wild frontier, what we're doing. So we had a customer ask us that when 3 of our satellites were flying over a specific longitude and latitude, they wanted to send the transmission up, and then they wanted to see if we could capture that transmission, bring that raw data down to them, and then they were going to cull that data to see if we actually captured that transmitter. We did that as a proof of concept to demonstrate that if it's inside of our frequency bands, we will try and capture it and bring it down. And if somebody has the skill sets, the data scientists, to get to that actual signal noise, we're happy to see if that can be done, if it means that there's an opportunity to help solve that problem going forward.
Excellent. So the next question here coming in is, how are you partnering with any universities for signal processing courses or just research in general?
So not in the sense of courses today, but being in the government business, we work a lot with the FFRDCs and we work a lot with the universities. When we first started the federal group, like I said, 2.5, 3 years ago, we had to have people test our data and validate our data that it was of quality and of ability to contribute to what they're trying to accomplish. So we ended up letting a lot of people try our data, both universities, FFRDCs, government agencies, so that we could get some written documentation about our data and how it's being used. So in that sense, we're not giving it to universities so they can use it in study classes with their students or whatever, but not yet today.
Excellent. How are you working with other RF collectors that are emerging in this space? Is there opportunities do they overlap with your business, or do you partner with them? How does that work?
Yeah, we are very interested in partnering, and we have in many cases. With AIS, we have married SAR imagery data to come up with a solution that can help find dark vessels. We have another partner that does acoustical data on the oceans, and we're marrying that with AIS data as well so that you can find things like subs and other types of vessels. So what we look for is if a client that we're talking to has a specific request around a mission, then we're going to put together the best team, and it doesn't matter whether we're prime or sub, to solve their problem. So if it's other RF data, if it's other types of data, we're happy to figure out what that solution might look like and how we can solve the customer's problems.
Excellent. Can you talk about how many partners that you have in your network right now, just that you're working with?
Well, I look at partners both being the SI community that is taking our data and merging it into a fusion of some other type of view. There are weather companies. There are other AIS providers. So it's very broad. We spend as much time looking at partner relations as we do direct to the end customer. I actually will be having a rec on the street here next week for a channel partner. We've grown to where we need to have somebody dedicated and focused on that on a regular basis and providing a regular cadence of information to help solve these problems that we don't see.
Excellent. As we're waiting for more questions to come in here, Keith, I think one item that we didn't touch on earlier is what concepts and projects are you in development for the rest of 2020 and going into 2021?
So we don't talk a lot about our roadmap, but I would tell you that one of the things that we have done, we're now on Lemur 4. Lemur stands for a low Earth multi-use receiver. And we started with Lemur 1. We have a saying in our company, it's launch and learn. So every launch that goes up and every satellite that's deployed, we are learning a lot about what's working, what's not working, what should we do differently. We have a tremendous engineering department and manufacturing firm group that is really evolving that process and miniaturizing our technology to incorporate other types of capability, whether it be supercomputing, whether it be GPUs. All of this is what we're considering as we move forward on what we're going to do as we evolve our satellites. And we can cram and pack a lot of stuff in a 3U. We are also now been under contract with a European organization about looking at 6U, and we actually have some government organizations that are looking at 6U. So we're actually expanding our bus from 3U to 6U if the business model is correct.
What's the size difference there?
3U.
Okay. For those who are not familiar with the 3U and 6U, the formats.
Yeah. So basically, you have a 10 by 10 by 10 if you want 3 of those, and then you're going to take that to 6. The actual measurements of a 3U, let me double check. It's, hold on 1 minute. Yeah, it's a 120 millimeter by 90 millimeter by 80 millimeter. It's 1,500 grams. We have anywhere from 5 to 12 watts of orbit power, and then we can get maybe 35 watts max. So it is kind of like putting a server in space. We're really bringing the capabilities and the technology that can really make a difference.
Well, this is an interesting question coming in. First off, how fast do you iterate on new versions of your constellation or your satellites, and over the course of the year? Because I understand with the emerging space now, rapid innovation is definitely the thing that's been going on, and I imagine that Spire is doing something similar with that, especially as you just highlighted what you're trying to evolve to with the 6U, but also to go along with that. Because so many emerging space companies are coming out there, there's starting to be a huge backlog in launches. Has that affected you all in terms of scheduling, or do you have a consistent schedule that you are putting new satellites up or plan to put new satellites up?
So we build a satellite every 6 weeks, and we launch within I'm sorry. We build a satellite one a week, and we launch every 6 to 9 weeks. So we're a ride share. So we can box up our satellites and get on any one of numerous launch vehicles, whether it's Rocket Lab, SpaceX, PSLV India, and so forth. But the more important answer to the question was the iteration process. We were founded in 2012. We launched our first satellite in 2014, and that was a satellite not to look at the payloads, but was to check the platform and the support systems. And then that was Lemur 1. And then in 2015, we launched Lemur 2, which had four payloads on there. And so now here it is 2020, and we're on Lemur 4. So from 2014 to 2020, we've had 4 iterations of our Lemur 1 through 4. So that's kind of the speed of what we're doing and iterating on.
I'm just still kind of floored by what you just said from a 6 to 9 week launch period. That's incredible.
Yeah. So, like I said, we have a variety of launch providers that we've done. We've done 20 plus launches since 2014. We started out with Antares. We did Detner. We did PSLV. We've done Soya, Rocket Labs. So, and Electron. So we've done a host of launches with a host of launch vehicles.
Well, I think that's the questions have kind of tapered off here coming from the audience. Is there any last minute plugs that you like to give for Spire or any projects going on, or for yourself for that matter?
I would just say thank you so much. The one thing about Spire is all the employees are extremely passionate about what we're doing. We really believe that we are making a difference. When you look at our weather product, it is so sophisticated that it really will help change the way we live on this planet, and it's exciting to be part of. And when you look at our payloads, those are things that are also, from lost airplanes. Everybody who had a loved one on any of those major crashes that we didn't find the planes, having ADS-B and tracking planes is really going to make a difference and help with some of that kind of environment. And the same with ship tracking. The ability to keep these ships safe and sound from weather and from other types of things. So we're doing some really neat things, and we're trying to solve missions that really are critical to everyday life.
Excellent, Keith. Well, I want to thank you for joining us, Spire for coming on and participating in the Geospatial Frontier Virtual Technology Fair. I think getting insight to your company has been incredibly valuable for our audience on multiple levels. And just to understand what types of sensors are on board commercially or how they continue to evolve. Once again, I think just learning about the launch process parallel to the data you provide is really eye-opening here. So with that said, we're going to, I want to thank the audience's patience with the audio. We're going to clean that up after the fact. And if anybody missed this is going to be up by the end of the day. You can watch throughout the rest of the conference and thereafter for that matter. With that said, I'm Adam Simmons here with Keith Johnson with Spire, with Project Geospatial and the Geospatial Frontier Virtual Technology Fair, signing off. Thank you very much, everybody.